Hello students, welcome you all. This is your coach Vinay and you're watching Science Thesis for You. In this video, we're going to talk about few organic reaction which students have found difficult to understand. This video is for class 11th, 12th students and those who are preparing for entrance exams. So without further ado, let's get started. Alright, here they are. First, regioselectivity. Second is stereospecificity. And third one is stereoselectivity. We're going to learn all those three in detail. But before starting, I just want you to understand two terms: selective and specific. I'm going to give you one situation. In this picture, you can see there are four types of ice cream. And students, they like ice cream a lot. I just want to ask you one thing. You have to choose one out of all those four. You might be thinking, sir, I want all of them, but no, you have to select one. So whatever you are going to like, you're going to select. This is called selection. Now again, I'm giving you a situation, another situation. Here in this picture, you can see three ice creams, but of the same type. I again ask you to select one. You might be thinking, sir, there is no selection. I have to specifically take one because they are all same. So this is the difference, selection and specific. First, regioselectivity. What is regioselectivity? A reaction in which two or more products you will get, and all those products are constitutional isomers, and among them one is the major or the dominating products. Let's talk about some examples, have the better understanding. So here this is alkene. Alkene you all know. HBr here we are taking as a reagent, and this is electrophilic addition reaction, and you know this is going through MK rule, that is Markov-Nikov rule. In short, I will tell you this is MK rule. Okay, so what will going to happen? The Br will going to attack either side, and according to the MK rule, this would be the major product because negative part goes to that carbon which is having less number of hydrogen. Yes, so this is the major product, and this is, of course, I haven't written, but this is a minor product. You can see both these two products, they are isomer. Yes, they are constitutional isomer. One is the major, and this reaction is regioselective. Again, one more example. Again, we got the alkene, and here this is acid catalyzed hydration, and again OH will going to attack either of the side, and here we got these two products. This reaction followed MK rule, again Markov-Nikov rule, and this is the major product and this is minor product. Again, you see both the products, they are constitutional isomer, and this is the major product. Hence, this reaction is regioselective. You can select, this is the major one. One more example, same alkene, but the reaction I have changed. This is hydroboration oxidation, important reaction, and this will not going to follow MK rule. It is going against anti-Markovnikov rule. It will going to follow, and you can see two products, but the latter one this side is the major product, this one. Okay, so again you can select this one. So this is regioselective. Make one point, both should be constitutional isomers. Okay, let's talk about one another example. This is quite different. Elimination reaction. On the elimination reaction, we're going to see regioselectivity. Okay, you just see this is alkyl halide and here is Br. It's a leaving group, and here we are taking E2 elimination. Okay, this is a base. Base have to take H, that is beta H, from either of the side it can do, and we get two products. Okay, so the two products both are alkene. One is Setzev product and another one Hoffman. Setzev product is the major product. You can see both are isomers, constitutional isomers, and Setzev one is the major product here in this case. And you can see, you can select this out, and this is known as regioselectivity. I hope you got it. Second reaction is stereospecificity. Let's talk about it. A reaction in which a reactant gives you a product. Another reactant, which is a stereoisomer of the first one, is also give you another product. And both the products are a stereoisomer. It is quite confusing, but don't worry, we're going to understand through an example. So this is SN2 reaction, substitution 1, and here we have reactant 1, reactant 2. You can see this is R configuration and S configuration. So both the reactant should be stereoisomers which you are taking it. It can be RS configuration, cis, trans, EZ, etc. So here the R configuration, the first reactant is doing the substitution OH minus. Here it is nucleophile going to attack from the back, as you already know this, and we're going to give you the product which is different, having S configuration. Again, the reactant second, which is stereoisomer of the first one, you can see the S configuration going through the same reaction. The reaction should be the same and give you the another product, and that is R configuration. You can see they are stereoisomers, and again the products, they are different but stereoisomers. Again, we're going to understand this thing through an elimination E2 reaction, which is also stereospecific. Let's begin. So here we have the reactant 1 and reactant 2. Both have relation. Yes, both are stereoisomer. You can check through the configuration 2s3s and 2r3s. You can see the configuration is quite different and they both are stereoisomers. Again, the reaction is happening, OH minus giving you the product, this elimination reaction. So we got alkene over here, this is having configuration E, so it's a different product. Again, same reaction occurred and you got the Z configuration. The products are different, but they are also stereoisomer. Okay, let's talk about one more example. Third, addition in alkene. Here we are going to study the bromination, and there this is one reactant 1 and this is reactant 2, cis and trans, right? They both are stereoisomers. Let's talk about the first, cis. Br2 addition is going to happen, and here the products you see they are enantiomers. All right, and now we're going to see the trans reactant. Again the same reaction, Br2 addition, and let's see the product. The product is meso. The products are different but they are stereoisomers. So stereospecific reaction, again you understood I guess this thing, that the reactants, they both are stereoisomers, they giving the product, they are also stereoisomers. Let's see a few more examples. Hydroboration oxidation. Here you see hydroboration oxidation, another hydrogenation, epoxidation, Dielders reaction. These all are examples of stereospecific reactions. Here is the final reaction, stereoselectivity. What the stereoselective reactions are? A reaction in which two or more products you will get. All the products are stereoisomers of each other, and one is the major product, that is the dominating one. One thing you should always remember, this selective and specific term. Selective you have to correlate with the product, while specific you have to correlate with the reactant. If the selective term is there, just look the product. And if it is major, yeah, of course, there might be some selectivity kind of a reaction. So, stereoselective reactions are of two types. One is distereoselective reaction and the another one is enantioselective. First, we're going to start with distereoselective reaction. First reaction, distereoselective reaction. So here is a reactant which is having the double bond, which is going to reduce through the hydrogen platinum, and it is a syn addition. So you see this reactant is giving you two products after reducing. One is a cis and the other one is trans, and cis is the major product 68%. And you know stereoselective reaction, the reactant give you two or more products, one is the major product, and here it is. So this reaction is stereoselective, and of course it is distereoselective reaction. One important thing is why this cis is 60%, which is major, why this thing is happening. So let's talk about that. So hydrogenation is a syn addition, And let's talk about this double bond. And you see this CH3 is having wedge, it is means it is coming towards you, and hydrogen it is going down. And let's see, we are having the addition from here, from the front, and the other way is to from the back you can do the addition. So let's talk about from the front. So first of all, we are just adding the hydrogen from here. So what will going to happen, the CH3 will goes at the back, and the hydrogen will stay over here. So you see the hydrogen and CH3 it will goes at the back. So the trans product you will get, you can do the addition from the back as well. So like this, if the hydrogen will going to add from the back, CH3 will come out, and the hydrogen will going to attach where, at the back. Now you see which addition is quite easy. Here if I add hydrogen from the front, the CH3 is also here, so the repulsion would be there. This won't be happen in case when I am going to add from the back. So that is why this cis, the configuration is 60% because of this CH3 repulsion is not there when the addition is happening from the back, and that is why it is a major dominating and hence selective reaction. Second is enantioselective reaction. So here, this is the reactant cyclohexene I have taken, and the addition is Br2 addition, and it is anti-addition. We'll get the product. This is anti-addition, right? So we'll get the trans is the one product, and the cis is the second product. And you all know anti-addition, so the major product will be the trans product. Here also we got two products. One is the major product, and both are basically stereoisomers. So it is the stereoselective reaction, and it is an enantioselective reaction. Let's say talk about another example. Examples like hydrogenation of alkynes through Lindlar catalyst, that is syn addition, and Birch reduction, that is anti-additions, are also stereoselective reactions. Alright guys, I hope you enjoyed the video. If you did, please like the video, subscribe my channel, and if you want to say something about these kinds of reaction, any sort of problem or any question, please text me in the comment section below. I'll be waiting for your comments. Thank you.